Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem fractional knapsack. So this is a very famous greedy algorithm problem. So what we can do here, we are given two arrays, value and weight, representing the values and weights of items and an integer capacity. So basically we are given a value array and weight array, and we are given a knapsack is nothing but a bag, and the capacity is the maximum weight the knapsack or the bag can hold, and we have to determine the maximum total value that can be achieved by putting items in the knapsack, and we are allowed to break the items into fractions. All right, so we have to return the maximum value we can store. Maximum value we can we can just we can just attain after filling the bag with the whole capacity. So if I take this example one here, so we are let's say given a bag, all right, and capacity of this bag is 50, let's say 50 kg is the capacity, all right, and we are given three items, and weight of each item is given, and the, what do we say, value or the profit which when we put the items. So these are item 1, item 2 and item 3. Each item's weight and profit or value is given, and we have to fill all the items into this bag, and we can if if an item doesn't fit into it, we can just break that item. That's why it is known as fractional knapsack. And we have to fill this bag such that we attain the maximum value or the maximum profit. So if we fill this 10 kg item, so if we fill this 10 kg item, so weight will be 10 kg, and we are now left with 40. All right, so initially it was 50 and we are now left with 40, and profit will be 60 rupees. Profit will be here 60. Now we are left with 40. So now what? If we fill this 20 kg weight, so we are now left with, if we fill this 20 kg weight, where profit will be 100, so this will become 160, and now we are left with 20 kg. Now again, if we are here, this is 30 kg item, we can break this into something such that we from this 30 kg item we store here only 20 kg. So how can we break this? This can be easily broken by, if 120 rupees is coming from 30 kg, then 1 kg will cost 120 upon 30. All right, so 120 upon 30 is what? 4 rupees, and we need to store here 20 kg, so this will be what? 20 into 4, so this will be 80. So this will profit us 80 rupees, and now bag will be empty. So 160 plus 80, this will be 320. All right, not 320, it will be 240. 160 plus 80 is 240, so this will be now 240. So this is one of the way that we blindly trust the order, and just we put all the items one by one, but it will not give us the maximum profit. In this case it is given 240, but not everything, not every time. What if this 20 was before was item 1, and what is this 10 kg item was item 3? So order is not mattering here. So what we should, what do you think, what which item should we fill here first? So if we have to fill this 40 kg bag, and we need to maximize our profit, so what do you think, which item should we fill here first? The item which is giving us the maximum profit, the item which is giving us the maximum profit with minimum quantity. All right, so if a item with maximum profit and minimum quantity, maximum profit and minimum quantity is there, so what will happen? It will fill, it will take less space and will give maximum profit. So what we can do, for every item we can check the per kg profit. What is the per kg profit? So how we can know? So we can just create here, I should delete the above thing, and per kg profit, let's say per kg profit is what? So if we divide the value by weight, so it will give us per kg profit. So this will be 60 by 10, that is 6. This will be 100 by 20, that is 5. And this will be 120 by 30, this will be 4. So an item which is giving 6 rupees per kg, and this item is giving 5 rupees per kg, and this item is giving 4 rupees for 1 kg. So which item we will fill here? For the same 1 kg, which item we should fill here? So I should fill here first this item with the maximum profit per kg. So I will fill this item, I will sort this, I will sort this whole value and weight array according to this per kg profit. I can use a comparator, and now I will fill this. Now first I'm here, so this is giving 6, so this is already correctly sorted here, so I don't need to shuffle value and weight arrays. Now first this is maximum, so I will say that fill all of them till we have the capacity. I will store maximum of this item, so I will check the weight of this item. If it is less than the capacity, I will take all the items, whole item, that is 10 kg item. So now I will take all the item, 10 kg item, and now my profit will be, my bag will be now reduced to 40 kg, and my profit will be increased to 60. All right, so this will be now increased to 60. And now moving to next, moving here, so I will try to store maximum of this item. So what is my capacity? It is 40 kg. What is the weight? 20 kg. It is less than 40. I will take whole item. So taking whole item will profit me 100 rupees. So plus 100, this will give me now 160. All right. So this is now 160, and profit is ready and capacity is reduced to 20 kg. Now I will move ahead. I am here. I will try to take maximum of this item. So amount, weight is 30 kg, but capacity is 20. I have to take less item. I have to take just 20. So what I will do? Again the previous thing. Value by weight per kg. What is the price? This is 4. Now 4 into 120. 4 per kg profit is 4 and we need just 20 kg. So 4 into 20, this is 80. So this amount of money profit we will gain. So 160 plus 80 will be 240. All right. So my capacity will be now 0. Now we will just break. Whenever we will see that our weight is less than the capacity, we will break after uh, updating the profit, because then we will getting 0 only. Now if I go to implement this, so first of all I would like to declare the size of the knapsack, that is size of the n is number of the items. Now I would store them in pair of vectors, and this will be VP. Now I will store them val of I, comma weight of I. Now I have to sort them, but I have to sort them with respect to value and weight ratio. So I will use comparator. So my sort function will be like vp dot begin, comma vp dot end, and here my comparator I will write. So my comparator will be auto and A, auto and B. We all know the syntax for writing comparators. If you don't know, you can just check on Google or YouTube. So if you will ask me, I will also explain. I will create a video on comparators. Now in the comparator, what we want that A dot first, that is in a pair value to the weight ratio, A dot second should be greater than, it should be arranged. So A dot second divided by A dot first will be here, or this will be B dot first. And yes, we should deal with float values also, because we are dividing and we need to sort them correctly. So now this will ensure me that sorting is done according to the value weight ratio, and after sorting is done, I will just store, I have to return the answer. So my answer, let's say, is 0.0 and it will be in double, and now moving inside the pair of vectors that are sorted, I will check that if VP of I dot weight, that is second, if it is less than or equal to the capacity, then our profit will be what? Will be increased to VP of I dot first, that is the value. This will be, this way our profit will be increased. We will take the whole profit, and our capacity will be reduced by the weight, that is VP of I dot second. And in the else case, if we have to deal with fractions, So I would say that just add the fraction as what will be the fraction value upon weight. So this will be value upon weight. So I would say that this will be VP of I, value is first thing, so first divided by VP of I dot second thing, that is the weight. So we got the ratio here. Alright, and ratio, if I am dealing with ratio, so I should write here 1.0 also into how much capacity is left. This way we will store what is the maximum profit we are getting, and at last I will return the answer. And let's submit it and check if we haven't made any mistakes here. So we have done some mistake here, some little mistake. So we have declared the size of the array with val dot size. We are creating pair of vectors, and we are storing also val of I and weight of I. Then we are sorting it, and we are sorting it correctly, and then two pairs will come, and I will say that check A dot first upon A dot second, that will be value to the weight ratio. This will be A dot first upon A dot second, and for storing correctly I will say that multiply it by 1.0 first and then divide. So why not should I use here some brackets to just be safe from the precedence, because I do not remember the precedence order right now. So why not to use brackets directly? So if I correctly use brackets, now here also if I use brackets, and now if I write here 1.0 into B dot first divided by B dot second, and first of all 1.0 will be multiplied with B dot first, then it will be divided by B dot second, and then this bracket will be closed. Now my answer will be double, and my answer is double z port 0.0, and I will iterate to I will go to each and every indexes items, and I will check the value to the weight ratio, and if VP of I dot second, that is the weight, that is here it is 10, let's say. If it is less than equal to the capacity, I will say that increase my answer profit to 60. So this will be VP of I dot first, and reduce the capacity to 10 kg. So this will be subtracted with VP of I dot second. In the else case, my answer will be updated with VP of I dot first, and then I have to break. And if I submit this now, so we can see we have solved this problem now successfully. And if I tell you this time and space complexity, So time complexity, we are using first of all this big O of n, then this sorting will take big O of n log n, then again a for loop of big O of n. So overall this will be big O of n plus big O of n log n. So I would like to say this as at max big O of n log n according to the time complexity rules. The larger will win. And space complexity, I am using this pair of vectors to store the value and weight, otherwise I am taking nothing space. So this will be of n. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.